I'm going to talk about energy and the law of conservation of energy. So what is energy? It's something that can produce a change in matter. When a change in matter occurs, work has been done. So therefore, energy is a measure of the capacity to do work. Energy is something a body possesses. Work is something a body does. Work is accomplished only when a force succeeds in moving a body that the force acts upon. So work equals the force, capital F, times the distance moved. If a force does not give rise to motion, no work has been done. The unit of measure for work is the joule. Energy can't be depleted, it can be transformed. So energy can't be completed, it can't be destroyed, but it can be transformed. And when we're talking about pendular motion or sound motion, we have potential energy, which is stored energy, and kinetic energy, which is the energy of motion, and the potential and the kinetic equal the total energy. So this is stuff that we already know. Kinetic energy be at a maximum at equilibrium when the pendulum or the air molecule is moving at its fastest, and potential energy will be zero at equilibrium when the molecule or the pendulum is at its home base. Now kinetic energy is at a max, well, at equilibrium we know that. Potential energy is at a max when the pendulum is at maximum displacement, because that's when it most wants to get home to its equilibrium. But the kinetic energy is at a zero at maximum displacement when the motion is momentarily halted. So there's this back and forth between a gain in kinetic energy as the pendulum approaches equilibrium to a decrease in kinetic energy as it moves away from equilibrium to an increase in kinetic energy as it moves back towards equilibrium, and back and forth and back and forth. And the potential energy is doing the opposite. So potential energy is a zero at equilibrium, but then the potential energy is getting greater and greater and greater as the pendulum heads to maximum displacement. Then as it turns around, it's getting, when it reaches its max at maximum displacement, and then it goes down, down, down as it reaches equilibrium, up, 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 up to maximum displacement, and back and forth and back and forth. And that's the energy that, that's this transformation of energy, this back and forth and back and forth, but the total energy remains the same. So at all points, the total energy remains the same, and that's in accordance with the law of conservation of energy. Now, vibratory motion does not continue indefinitely. This is because of the opposition to the motion by the force of friction. Remember, so I said eventually the restoring force wins. Why does the restoring force win? With friction. Friction opposes or resists motion, and it serves to limit velocity. So friction on the bob of the pendulum due to air resistance causes energy to be transformed from kinetic energy to thermal energy, right? So the energy is not created or destroyed, it's transformed to thermal energy, and with each excursion of the pendulum, the amplitude is less than the one before. So eventually the swing stops swinging because of frictional resistance. The diminishing amplitude is referred to as damped vibration, frictional resistance, or just resistance. So there are two characteristics of pendular motion: the amplitude of displacement, which is a derived physical quantity, a vector quantity that incorporates both magnitude and direction. It's directly proportional to the force applied. So the more force you apply, the greater the amplitude of displacement. The next characteristic is frequency, or the rate of vibratory motion. Frequency, the number of cycles completed per second, and a cycle would be from equilibrium to maximum displacement to equilibrium to maximum displacement in the opposite direction back to equilibrium. That is a full cycle. If a pendulum completes 4 cycles each second, its frequency is 4 cycles per second. If the rate of motion were increased, so that 25 cycles are completed each second, then the frequency is 25 cycles per second. Now the unit of measure has been changed from cycles per second to hertz. So 4 cycles per second is the same as saying 4 hertz. Frequency is measured in cycles per second, hertz, right? So frequency, the number of cycles per second, hertz. Period is the number of seconds per cycle. So it's the reciprocal of frequency, the number of seconds per cycle, the amount of time that is required to complete one full cycle of vibration, and period is a capital letter T. If a pendulum completes 4 cycles of vibration in 1 second, its frequency is 4 hertz. Then 1 cycle must be completed in 1/4 a second. Therefore, the period is 0.25 seconds. If the frequency is 25 hertz, 1 cycle must be completed in 1/25 of a second, and the period is therefore 0.04 seconds. So period equals 1 over F. F equals 1 over period. They are reciprocal. They are not independent values. The value of frequency determines the period, and the value of the period determines the frequency. So, go back to when you were little and you were at the playground and there were swings. Which swing was the most fun swing? Was it the swing that was very low to the ground or the swing that was up higher? The swing that was up higher was more fun. And that's because the period of vibratory motion is directly proportional to the square root of the length. So you knew at an early age that the swing with the shorter length had the higher frequency and was therefore more fun. Frequency and amplitude are independent of each other. So amplitude is directly proportional to the force applied. Frequency is inversely proportional to the length of the string, the length of the pendulum. So the lower the swing, the longer the frequency. The lower the frequency, the less fun.